Okay, let's dive right into this explainer and demystify the massive buzzwords surrounding generative AI. I mean, we are hearing it absolutely everywhere these days, right? From the evening news to the boardroom. But to truly understand what's actually going on, we need to zoom out a bit and place it in the broader context of computer science.
So here is our roadmap for today. First, we'll map out the AI family tree. Second, enter generative AI. Third, looking under the hood. Fourth, the GPT evolution. And finally, risks and real-world impact. All right, section 1, the AI family tree, zooming into the buzzwords. To start, think of artificial intelligence as our outermost Russian doll. It's the big umbrella that encompasses everything. We're talking from the basic non-player characters in your favorite old video games, all the way to the highly advanced chatbots we're using today. At its core, AI is just a set of techniques used to create machines capable of performing tasks that typically require human intelligence.
Now, within that outer doll, we find a pretty massive divide: symbolic AI versus predictive AI. Symbolic AI uses rigid, human-coded if-then rules. It basically relies on human experts to build a giant decision tree. But predictive AI, or machine learning, learns completely autonomously from data. So instead of a human writing a rule that says, hey, if a user is 25, show them this product, the algorithm just looks at mountains of data, notices that a user named Bob likes the color black and running, and predicts he'll probably buy black running shoes.
So zooming in one layer deeper into that predictive side, we get to machine learning itself. This is where algorithms crunch vast amounts of data to guess how unseen data is going to be distributed. The whole goal is to detect underlying patterns. If the machine can figure out the hidden logic behind the data it just analyzed, well, it can make incredibly smart predictions about the future. Zooming in again, we find neural networks. These are actually inspired by the human brain. The algorithms use mathematical weights, which you can kind of think of as dials being tuned on a soundboard, and biases that function as built-in thresholds. An input signal comes in, flows through these nodes, which are organized in layers, gets multiplied by those weights, shifted by the biases, and finally gives us an output. And if we take those neural networks and stack them incredibly deep, we get deep learning. The definition is literally just a neural network with more than 3 layers. But that added depth is a game changer. It allows the machine to capture incredibly intricate, hierarchical representations of data, which is absolutely crucial for complex stuff like speech recognition or navigating a self-driving car. Moving on to section 2, enter generative AI, a paradigm shift in AI. So historically, deep learning was mostly used to classify things. Asking, is this email spam or is this a picture of a cat? But generative AI flips that script entirely. Instead of just classifying existing data, it actually creates entirely new content based on your natural language prompts. And because you can just talk to it like a regular human, it makes these highly complex mathematical models accessible to absolutely everyone. Seriously, no coding degree required. Which brings us to section 3, looking under the hood. How do these models actually work? Well, it really all comes down to how these neural networks are trained. First, the model makes a guess. That's called the forward pass. Next, it calculates its error using a loss function. Then it performs a backward pass, which is a process known as backpropagation. Basically, the error gets sent backward through the network, and the algorithm slightly adjusts those dials and thresholds we talked about so it gets smarter next time. It literally repeats this trial and error process millions of times at lightning speed until it becomes incredibly accurate. Now, we absolutely cannot talk about this without breaking down the most famous acronym in the entire space: GPT. The G stands for generative. This simply means the model creates new sequences of text. It's not just sorting or categorizing existing text, it's building something brand new, word by word. The P stands for pre-trained. This means that before the AI ever even talks to you, the model is left completely unsupervised to crunch through vast amounts of data, pretty much the entire open internet. Through this massive pre-training phase, it develops its own understanding of the fundamental rules and relationships of human language. And the most crucial piece of the puzzle is the T, the transformer. Introduced in a famous 2017 research paper, this specific architecture completely changed the game. Before transformers, models had to process text sequentially, one word at a time, which was incredibly slow. Transformers process data in parallel, drastically reducing training times. They also use what's called an attention mechanism, which allows the model to figure out exactly which words in a sentence are the most important to focus on for context. So when you actually interact with a GPT, the system breaks your prompt down into what are called tokens. These are just small chunks of text. Then it plays a massive, extremely high-speed game of finish the sentence. Relying on all that pre-training from the open internet, its neural network acts like rolling a set of weighted dice to predict what token should logically come next. It's essentially predicting the next most likely chunk of text, over and over and over again, to form a coherent response.
Section 4. The GPT evolution from 2018 to the multimodal present.
The speed of this evolution has been, frankly, staggering. What started as a 117 million parameter proof of concept with GPT-1 back in 2018 scaled incredibly fast. By 2022, fine-tuning had turned these raw text generators into highly practical conversational assistants with ChatGPT. And by 2023, we saw the multimodal GPT-4. Multimodal just means it doesn't only process text anymore. It can understand images, audio, and complex charts right alongside your words. Just a quick point of clarification on the terminology here, because it can get confusing. Keep in mind that while all large language models, or LLMs like ChatGPT, are generative AI, not all generative AI are LLMs. Basically, generative AI is the massive umbrella category that also includes your image and video generators. LLMs specifically specialize in just text and language tasks. And finally, Section 5, Risks and Real-World Impact, Practical Applications and Ethical Boundaries. Gen AI is rapidly becoming our everyday co-pilot. The sources highlight an incredibly wide range of real-world uses. For software developers, it's writing code for full React web apps. In risk management, it's synthesizing historical patterns for fraud detection in finance. It's automating customer support triage, parsing really complex bank documents, or just handling relatable everyday tasks, like writing a silly poem about your boss. It has truly become the ultimate multi-tool. However, an impartial analysis of the sources shows significant technical limitations that organizations absolutely have to manage. These models can confidently hallucinate incorrect facts, completely fabricating information out of thin air. And because they learn from vast amounts of historical internet data, they can reflect and amplify existing biases found in that data. Plus, using these models without proper oversight can expose users to copyright and legal issues, as well as data privacy violations. Which brings us to an incredibly important framing from our source material. GPTs are powerful pattern learners, not infallible oracles. We have to always remember that despite feeling like actual magic sometimes, these systems lack grounded, real-world knowledge. They aren't thinking like human beings. They are merely modeling the statistical patterns of human text. And that leaves us looking forward. Today, we've zoomed all the way from the broadest definitions of artificial intelligence down to the actual mathematical weights of a neural network and back out to the real impact this has on our world. The big question going forward isn't just what generative AI can do, but how we adapt to responsibly use it. So, how will you choose to integrate these imperfect but revolutionary tools into your future? Thanks for exploring this with us in today's Explainer, and keep learning.